Yes. To close the microphone here and take a look at this. Hello, test. Okay. New person, right? Timing. Yes, sir. มีใคร จะค่อยมาแล้วไปแล้วนะครับ and who else nothing alright yep and okay so we'll show it in time okay this one right and, yeah it's the M604 right yes sir solid liquid right this one yes sir we arrive at this one and Petra okay all right yes good morning everybody, welcome you back to the SCI33206. We are live at the topic of fluid pressure and buoyant force, right? What you can see here is different kinds of fluids, right? You know that fluids include both liquid and gas, right? So, but this one we are going to talk mainly about the liquids. So, in liquids there are, as you know, there are so many types of liquids, and yeah, once they stay together, we try to keep them in the same container like this, so they would not be mixed themselves together. They try to stay separately. Okay, it depends on the density, right, to each one. And all right, okay, and yeah, we will see the first property, which is the density, right? Density is measure. I hope that the sound is okay, right? Density is the measure of the amount of matter per unit volume, and yeah, and the density is the mass divided by volume, simply speaking. And we use usually the Greek letter rho, right? RHO, rho, to denote the density. And what else? Nothing more, right? And yeah. We use the Greek letter RHO, rho, to denote the density. And if the mass M of material has a volume V, so from this definition, we are gonna have rho equal to m divided by v. And as you know, in physics, the unit is also important. And let's get into the detail. Maybe you have seen this stuff already. The unit of the mass is the unit of the mass is kilogram, right, in the SI system. And the unit of the volume is cubic meter. So the unit, SI unit of the rho or the density is kilogram per cubic meter. All right. And yeah, density also depend on temperature and pressure. So yeah, if it depends on the way atoms stack together in solid. Yeah, if it's tightly stacked, so we have more molecule or more mass in a certain volume, and we would have a greater or higher density, right? For some elements have many allotropes or form, okay, in chemical or in physics. In our story, we would say allotropes. For example, graphite and diamond are both solid form of pure carbon, and yeah, they are both made of carbon, but they have different structures. So yeah, they have different densities too, right, and other properties. Yeah. What else? Gases are less dense than liquids. That's typically, right? In which are less than solids. Yeah, it would have less density than solids. And however, there are many exceptions. For example, ice, which is a kind of solid, like of water, is less dense than water. Okay, in this case, the solid may have less density than the liquid form, right? And a few gases are heavier than liquids. For example, water is lighter than tungsten hexafluoride gas. All right. I don't know whether you have ever heard the tungsten hexafluoride. Yeah, it's a special kind of gas. Okay, it has more density than the water. For example, water is a liquid. So there are many exceptions. Okay, you may not. Yeah, if you want to do the pass some exam, entrance exam to some university, you may have to remember this. But in real life situation, we wouldn't use it. Okay, except that you work in a chemical company or spatial company like that. Okay, hydrogen is the lightest or least dense element of the periodic table. All right, and yeah, what else? The densest. Okay, if we talk about the lowest one, right? The highest one is that the densest material found on Earth. Okay, let's talk about the stuff on Earth. We didn't talk about the stuff outside our planet. The densest material found on Earth is the metal osmium, which has 20,000, right? 22,500 kilogram per cubic meter. Okay, which is very, very dense. Okay, and if we talk about the substance or the object outside our world, it would be the white dwarf star. White dwarf star is on the order 10 with a power of 10. All right, in neutron star, okay, and that of neutron star. Okay, I hope I guess that this would be the star that has only neutron, right? The astronomist would have some ways to predict or to observe the star that contains only neutrons. Okay, and in that star, they predicted that the density is on the order of 10 raised to 18, right, which is very, very high. Okay, this one is around 2 times 10 raised to 4, right? But this one is 18, okay, the power of 18, which is very, very dense. All right, and what else? Okay, let's get into the material on Earth. We have, for example, ice, right, which is less than water. Water is usually the water usually has 1,000 kilogram per cubic meter, right? But this one is less than that. Is less than 1. All right. Yeah, water is right here. These are all in solid form, right? In what else? These are all in solid form. But this one, this column provide the density for liquid form and gas form. This fluid. This one is the column for fluid. This column is given for the solid, right? Okay, if you take a look at heavy metal, for example, copper, silver, lead, gold, platinum, okay, they are all on the order of 10 raised to 4, right? But this one, okay, mercury even is a solid form, or is in a liquid form. It has its own density quite close to that to those in solid form. Okay, this is an exceptional case. All right. What else? I think nothing more, right? The one here is air, right? It is spatial, right? It's on the order less than 1,000. Okay, it's on the order of 1 only. For example, the air has the density of 1.29. Okay, and oxygen. Okay, air contains also nitrogen and other stuff, right? It would have less density because it contains some contamination. All right, yeah, we have to accept that that's nature, right? So we could not do anything. The oxygen has even greater density than higher density than the air. Hydrogen is even less dense than the air. Okay, it's only, that's the least dense, okay, the lightest, the least dense element, right? Hydrogen. And helium is another kind of gas. Okay, it's inert gas, and it's on the order 0.1 18, right? Kilogram per cubic meter. But note that the value on this table at standard atmospheric temperature and pressure, it's denoted by HTP, okay, and defined as 0 degrees Celsius and 1 atm. 1 atm means 1 atmospheric pressure, all right, and yeah. Together with 0 degrees Celsius and 1 atm, we are gonna call it is said to be a standard atmospheric temperature and pressure, STP. Okay, and one important thing, the so-called 1 atm is equivalent in the SI system to 1.013 10⁻⁵, okay, Pascal. And if you want to convert it to a smaller scale, like in chemistry and other subjects like that, if you want to be if you want to work in nutrition, okay, you may have to convert those quantity into a smaller scale, and it's called CGS, right? Smaller scale, smaller unit scale. And if you want to convert them to this smaller scale, you have to say you have to multiply by 1 10⁻⁻�3, which is equivalent to the division by 1000, right? Okay, and this one is from, oh, sorry for that. There is sound. Sorry. Okay, we would see the another table which also talks about density. It is taken from another book, okay, the book number 2, and yeah, the value is quite close to each other. Gases, right? It's 1.2. Okay, this is air, right? It's air. In this book they say 1.29, but both are quite close to each other. In for the liquid form, we have benzene, ethanol, water, benzene, ethanol, water, seawater also here, right? Please note that seawater is more dense, okay, than the normal water, the pure water, because we have also sodium chloride, right? And the blood inside our body is even more dense than seawater. Glycerin is another kind of it's in solid form, right? 1.26, and ice is a kind of solid. It's less dense than water, as we have seen. You can see ice is 0.97 and 0.92. Okay, both are quite close to each other. And here is a heavy stuff, aluminum, right? Heavy metal like iron, brass, copper, silver, lead, gold, platinum. Those are heavy metal, in even you faced with the bare earth material like gold or platinum, they are really dense, okay, like 19 and 21, but their price is also quite high. Okay, let's talk about the stuff outside our earth, our world. The first one is white dwarf star, which is 10 on the order of 10 with the power of 10, and neutron star, it's on the order of 10 this is 2 negative 19. Yeah, to obtain the density, you have to divide by 1000. Okay, that's the first basic term, right? You have seen เมื่อกี้มีไลน์นะครับมีไลน์คนหนึ่งไม่รู้ห้องนี้หรือเปล่าถามว่าแก้กันบ้านได้หรือเปล่านะคือคุณว่าไงดีผมให้คุณถามตัดสินใจกันโอเคไหมครับของปอตีผมให้แก้นะก็คือ0.75บางคนคิดเลขผิดอ่อนกว่าคุณอีกโอเคไหมเรียนอยู่วิศวะได้ยังไงปริญญาตรีนะครับกดเครื่องเลขกดไม่เป็นนะครับทศนิยมก็ผิดถูกนะครับเอาเป็นว่าผมเห็นใจสงสารนะแต่ว่ามันเพิ่มภาระผมนะครับเพราะว่างานชิ้นหนึ่งบางทีก็ตรวจกัน3 รอบ 4 รอบนะครับคุณแบบสเปะสปะหรือว่าไม่คิดอย่างรอบคอบนะครับคุณก็สักแต่ว่าส่งมานะไม่ได้ตรวจทานแก้ไขอย่างเดียวก็ผิดอยู่งั้นนะเป็นการเพิ่มภาระผมนะครับใช่ไหมเดี๋ยวขอดูที่ไลน์กลุ่มก่อนพวกที่อยู่ใน YouTube นะครับหรือว่าเข้ามาในซูมแล้วออกไปเข้ามาพิมพ์ชื่อเราออกไปก็ตามนะผมฟังเสียงคุณนะคุณจะรับว่าแก้ได้หรือไม่ให้แก้ครับพิมพ์ตอบมาครับเอาแฟร์ๆนะครับ604ว่าอย่างไร605ก็ว่าไปตามนั้นเพราะคุณน่าจะเลือกก่อนมีสิทธิ์ก่อนแล้วกันเนาะ604นี่604นะคุณนะครับคุณบอกว่าแก้ได้ไหมครับแล้วก็แอดชื่อผมมาให้ผมตอบเพื่อนๆว่าอย่างไรครับเพื่อนๆคุณอยู่กันไหมเนี่ยอยู่ที่ YouTube 2 คนทั้ง2อย่างละ2 ช่องนะแล้วก็ที่ซูมคุณอยู่กันไหมเนี่ย alright are you there ไม่มีใครอยู่นะที่ซูมนะครับซูมไม่มีใครเข้ามานะก็คุณจะยอมรับให้เขาแก้ได้หรือไม่ให้เขาแก้ครับ What do you think whether you would accept that your colleagues your classmates can edit their homeworks or not รุ่นพี่คุณอะไรเขาก็ไม่มีคุณนี่แบบสบายสุดแล้วนะครับการบ้านก็ไม่เยอะนะครับการบ้านอาทิตย์ละชิ้นแค่นั้นเองรุ่นพี่คุณน่ะอาทิตย์ละ2นะเรียนครั้งหนึ่งโอ้โหผมก็ตรวจเหนื่อยครับอันนี้คุณคุณทำเหมือนกันนะคุณลอกไม่รู้ลอกกันหรือเปล่าไม่อยากสบประมาทแต่ว่ามันเหมือนกันเดะผิดเหมือนกันเดะคนอยู่ที่ YouTube ครับคุณจะยอมให้เพื่อนเขาแก้งานได้ไหมคุณพิมพ์มาครับต่อมานะว่าให้เพื่อนพิมพ์งานมันเสียเวลาเรียนต่อดีกว่าโอเคfind the mass of the air and its weight in a living room with the dimension of 4x5 floor and the ceiling is of the height 3 meter what would be that's the first question right the mass of the air and what would be the mass and weight of an equal volume of water okay we are gonna need the same dimension right which is this one they have provided here 3x5 4 right that's the shape of cubic okay that's the shape of cubic and whether you what do you think whether you would this one right ผมแชร์ไปแล้วหรือยังหน้าจอ let me check whether I have shared it let me check whether yeah it's still sharing right it's still in sharing okay yeah the first question is to find weight a mass, right, of the air, and the second situation is that we will fill this room with we're gonna fill this room with water, right? So yeah, first we have to recall the formula of the formula of we're gonna recall the formula of density, right, which is rho equal, sorry for that, rho is m by v, right? And as we want to find m, so we are going to have m equal rho v and w, which is the weight, right? It's equal to mg, okay, the gravitational acceleration on Earth, right? Yeah, for the first case, for the air, right, we are gonna compute. Let's talk about the air. Okay, this is the air case, and m air will be equal to rho of air and the volume of the room, right? The V room. Okay, as we know, sorry, as you know before, rho air is available in the table, right? It's I don't know this one what they want to use. 1.2. Okay, they use the last table under the last table, which is this one, right? 1.2 kilogram per cubic meter, 1.2 kilogram per cubic meter, and the volume of the room will be its width and length and height, right? The multiplication of these three terms, width times length times height, right? And yeah, you would have with this 5, right? 5 length is 4 and the height is 3, right? So we're gonna have 60 cubic meter, right, like that, and that's the volume. And if you substitute this formula and this one to this expression, you're gonna have m air will be 1.2 times 60, and it's gonna be 72 kilogram, right? And now we are gonna convert the mass to the weight, right? And as we know, weight is mass of that object times the gravitational acceleration on Earth is 7 and 9.8, or you say sometimes 9.81, okay? And yeah, you just put it into the calculator, you're gonna have 705 0.6, right? And the unit for the force or the weight is Newton, right? Here, who is in the so okay, okay, let's check only one person. It's Napat เข้ามาคนแรก right, so Linapat, and yeah, let me send it to you so thatนะครับคุณอย่าลืมกติกานะครับตั้งแต่เทอมที่แล้วนะผมบอกไปแล้วว่าการบ้านอย่าลอกกันเนาะไม่รู้จำได้หรือเปล่านะการบ้านก็คืออย่าพยายามทำให้เหมือนกันนะครับมันสุ่มเสี่ยงนะ Okay, please try to change some details in that problem so that they're not going to be the same or replicated the replica to your colleagues. All right, don't use the same problem, or even you want to use the same one, you have to change the number somehow. All right, and yeah, let's get into the detail for the case of the water in this one, right? For the water, we're gonna use the same thing, which is mass of water. Mass of water will be rho of water times the volume of the room, and yes, of course, rho of water is the density of water, right? It's right here, which is 1000. Let's say it's pure water. So this one is 1000, right? Times 72, right? No, 60 cubic meter. You're gonna have 60,000, right? Kilogram, okay, which is very, very dense, and the weight of the water. The weight of the water could be easily found from M of water times G, right? And you have 60,000 times 9.8, right? And once you put it into the calculator, right, it's going to be less than this 5880. And it's Newton, right? ขออนุญาตนอกเรื่องนะครับเหมือนว่าโรงเรียนเขามีกำหนดการนะครับที่จะให้เรานั้นไปเรียนที่ห้องเรียนจริงครับก็5 กับ 21 เวลาครับงานโรงเรียนโอเค no problem นะครับก็หวังว่าคุณคือผมไม่บังคับนะมันเป็นสิทธิ์ของคุณเพราะว่าคุณก็เป็นทรัพย์สมบัติของคุณพ่อคุณแม่คุณเขาเลี้ยงดูคุณมานะครับบางทีคุณพ่อคุณแม่คุณเขาอาจจะไม่อยากให้คุณมาก็ได้นะผมไม่ได้บังคับนะครับใครจะมาก็ได้ไม่มาก็ได้แต่ว่าผมเป็นคนโตคนผู้ใหญ่นะครับผมก็ต้องรับผิดชอบนะครับถึงอยากไปไม่อยากไปผมก็ต้องนะก็ต้องไปนะก็หวังว่าคุณฉีดวัคซีนกันแล้วนะเพราะเขาลงให้ไวอย่างคุณฉีดกันได้แล้วนะครับก็รักษาเนื้อรักษาตัวนะครับก็ขึ้นกับคุณตัดสินใจนะเผื่อบางคนยังไม่ทราบข้อมูลครับ alright so we gonna go ahead with the next stuff the pressure, right? We need to introduce somehow the density, which is the common term, which is the a typical term, and yeah, it's very normal, right? This term, yeah. The pressure P, is defined as actually pressure has to be introduced before in the chapter of heat and gas, right? But we will talk about it again. Assume that you have never seen that the definition of pressure before. Pressure P on a plane surface. Okay, let's talk about a surface that is planar, and that plane has the area of letter A is the magnitude F with perpendicular subscript here, the perpendicular subscript of the force divided by the area. Okay, let's say you have an area A here, right? And you have the force, right, exerted on this area uniformly. Okay, everywhere has the same magnitude. And this one is F perpendicular. And you're going to have pressure, which is the ratio between the force, okay, exerted on that area, divided by the amount of that area. Okay, this force should be perpendicular to the plane of this area. Okay, the SI unit of the pressure, as you know, it's Pascal, right? Is in SI unit is going to be called Newton per square meter. All right, this unit is given by a special person, which is called Pascal, denoted by PA. The atmosphere is the layers of air wrapped around the Earth, and the air has a weight and pressure against everything it touches. Okay, whether you are tree, you are building, you are animals, okay, the pressure will act on you, okay, uniformly. Okay, it doesn't the pressure doesn't care what type you are, and the air works due to the gravitational force. Okay, the gravity pulls the air to you, okay, to pulls the air to the Earth. A barometer is an instrument used to measure the atmospheric pressure, and it's also known somehow barometric pressure. Okay, barometric pressure. This pressure varies with weather changes and with elevation. Okay, I think N is nothing. อันนี้ผิดเดี๋ยวตัดทิ้งครับ and if you don't understand, take a look at this. Okay, this is the almost the spherical shape, right? Spheroid, right? Because this side is greater than the side between the North Pole and the South Pole. Due to the rotation, right, as you have seen in the previous semester, the Earth rotates around itself, and the water on the sea, on the ocean, just has the centrifugal force, right? So it makes the shape from the perfect spherical shape to be spheroid, right? That's the reason. And if we stay on Earth, like in this area, and if we measure or build up or consider only the cubic, let's say it's a square area here, and we build up a height like this. Okay, column on air above us being pulled by gravity. Okay, of course, air has its own molecules or atoms, and Earth is a big object, and an object and another object would have their own attractive force, right? And that attractive force acts to us as the gravitational force. Okay, the air is pulled down by gravitational force, the attractive force between the air molecule and the Earth molecule, and atmospheric pressure happens to us like this. And if we take a look at the barometer, this type is called aneroid barometer. This figure is taken from a website in internet. I forgot to mention the source of this figure. contains a sealed box that expands or contracts, okay, or shrinks with the pressure, resulting in pulling or pushing a spring to move the pointer or the needle up and down, right? And yeah, it's gonna show you. Okay, there are also symbols like sunny day, cloudy day, and rainy day or something like that. Okay, nowadays that type of aneroid barometer is no longer in use. In modern system, I think even more modern than this, we have the so-called digital barometers. Okay, it gives you more precise results. Okay, in pressure measurement, they display it clearly. Okay, you don't have to get confused to several bars, on the circular scale of the aneroid barometer. You just simply realize the number that is illustrated on the monitor of that digital barometer. Okay, it's very, very, very clear. It's the same thing as in electric measurement device. Okay, the multimeter is now in the digital form. Okay, you just take a look at the numbers only, and you can easily realize that. And nowadays, the precision of digital device is better than those in the previous generation. Okay, and barometer has no exception. The newly modern design of barometer is in the digital form like this. Okay, atmospheric pressure (PATM) is denoted by P with subscript ATM. Okay, please note that it's not automatic teller machine. Okay, teller machine, which is the machine you withdraw the money. It's different. This is the atmospheric pressure. Okay, atmospheric is denoted by ATM. The pressure on Earth atmosphere, or the pressure of the Earth at the sea level, is this value. Okay, is denoted by atmospheric pressure. But if you go to the hill, the apex of Himalayas mountain, okay, you will not have this atmospheric pressure because you are really, really high above the sea level. Okay, your pressure is going to be lower than that. Or if you consider the pressure at the plane level, the airplane level, okay, because you are really higher than the ground, the floor on Earth, you would have less pressure, okay, than that for the people on Earth, on the ground, on the floor. Okay, the average atmospheric pressure at the sea level is measured at 15 degrees Celsius, and is used as the unit of pressure. It's called atmospheric pressure. And yeah, because pressure is the basic quantity, it's used in several societies in science, and in each society they would prefer their own easily correct scale, and it's called for example Pascal, right? Pascal is the SI system. 1 ATM is approximately 1.01325. Okay, you just use only 1.01, it's fine. Okay, but don't be so love to use only one time Taylor's to power less than 25 Pascal or Newton per square meter, right? The unit of that. And we would also say 100,000 Newton per square meter is equivalent to 1 bar, right? 1 ATM is not, okay, I would say is not 1 bar. Okay, ATM is not directly equivalent to bar. 1 ATM is approximately 1.01325. Okay, the same number here in front of those in Pascal unit. And if you, in some situation, they would call millibar. Okay, they want to observe the pressure in millibar, and the 1 atm is equivalent to 1000 because you have to multiply this one by 1000 and the units reduced by 1000, which is milli. Okay, 1013.25 millibar. And for those, for the people in the United Kingdom, okay, or in Great Britain, they would use their own unit system, right? It's called pound per square inch. Okay, power per square inch is the unit for the British system, and you may hear this one in if you work in a company in London, in England, and so on. Okay, and 1 atm is equivalent to 14.696 power per square inch มีใครพิมพ์ชื่อมาใหม่ครับไม่มีนะ and for the people measure with respect to the mercury level is gonna be equal to 760 millimeter mercury. And for the people in Great Britain, if they want to measure the pressure in relation to the mercury, it's going to be equal to almost 30, okay, 29.9212 inches mercury. Okay, you may see that pressure has various form, various units. It depends on which society you're going to work with. But for you at the high school level, we start from the SI system, Pascal. And if you go to the bachelor degree, if you are really interested in physics or in special kind of science, okay, you may encounter these spatial units. Okay, Pascal is used worldwide. As I told you, you can work it everywhere if you understand Newton per square meter or Pascal. Millibar or hectopascal is used by meteorologists. Okay, the people who deal with weather forecast and weather prediction and so on. Inches mercury is used in the United States. Okay, or not only in Great Britain, also in the United States, in the Biometric Formula is given by this one. Okay, if you are higher than the typical sea level and you want to find the relation of your pressure when you don't have the biometric, when you don't have analog barometer, you can also use this formula to predict okay, the pressure at your level. It's equal to it's made with respect to PATM. Okay, you need to know first this value, the pressure at 1 atm in whatever unit. Okay, just use it, and that's the value of PATM. And this is the exponential function, you know, right? Exponential function with the power of okay, when this one has the exponent of negative, it means exponential appear here as the denominator. And if you are higher, okay, your h is greater, this one has more division, right? A denominator, and the whole value is gonna decrease, okay, or reduce. So if you go higher from the sea level, let me open another good note. All right. If you go higher, yeah, above the sea level, okay, you go higher, you will have less pressure. Okay, you will have less pressure if you go higher from this column. All right, and yeah, if you stay on the planet that has more gravitational acceleration, you would have also less, right? Less pressure. And what about the relationship to temperature? If your temperature increases, you're gonna have more pressure, okay, because this is the division term. All right, yeah, K is the Boltzmann constant, which is equal to ideal gas constant divided by Avogadro number, right? You know Avogadro number. It's going to be introduced later. T is the temperature in Kelvin. Okay, you cannot substitute the value of the temperature in degrees Celsius. Okay, you have to add it by 273. What else? M is the mass of that molecule, of the air molecule. Yeah, let's get into the first example about the atmospheric pressure in the loom described in the previous example. Like in this example here, we have 5 meters of width, the length of 4 meters, the height of 3 meters. Yeah, in that example, we're gonna consider what is the total force on the floor due to the air above the surface if the air pressure is 1 atm. So how could we do that? Okay, that's the first example. Here's the second example. Okay, no problem. Yeah, for this example, they just asked about they just asked us about the pressure on the floor, right? Okay, that's the floor. The floor is gonna be here, right? Okay, let's draw it again. That's the lecture note for the M605. Okay, we draw it for us in this way. And the floor, of course, the floor is the lower side, right? And yeah, floor is right here, right? And of course, the area of the floor is what we need to determine, and it's gonna be width times height. Oh no, times length. The length of that room, and you would have 5 times 4, right? And it's equal to 20 square meter, right? Okay, and that's the thing we need to know first. Okay, and they say the pressure here to take place, okay, pressure, and they want to know F, right? They want to know F. What is F in this situation, right? F is F perpendicular, and the pressure here, they say P equal a PATM, right? Oh, PATM, right? The atmospheric pressure to this room. And of course, from our definition, the pressure is F perpendicular by A, right? And we are going to transform this expression for the force only, F perpendicular with the subscript of perpendicular, It's gonna be the multiplication of pressure and air and the air, right? The area, sorry, and the pressure, which is pressure at atmospheric times the area of the room, right? Area of the room, area of the floor. And you would have ATM, right? It's, yeah, as we know before. One ATM is this one, right? If you want to compute it in the SI system, we're going to use 1.01325 times 10 to the power 5. And the area is 20 square meter. And of course, you put it into the calculator, right? You're going to get 2.0265 times 10 to 6. And here is Newton, right? Yeah, all of this is the result, right, for the perpendicular pressure force. And yeah, what time is right now? 9:33. We're gonna leave our lecture at what is that? เราต้องจบที่ไหน 8:30 and 10:10, right? So we're gonna 9:50, right? We have still more 17 minutes. All right. Yeah. The next problem is this one, right? What happened? In figure 36, this figure, we have downward force is caused by air pressure, right? The air pressure is gonna push every object, not only this one, right, but also the whole water or liquid here. There is upward force, okay, is caused by the pressure of the water and must equal the weight plus the downward force. Okay, this is the weight of the water in this area, okay, in this volume, plus the downward force of the air pressure. Okay, there are two force by air, weight of this water column, and the force upward. Calculate the weight of a cylindrical column of water with the height of 40 meters. Okay, the height here is 40 meters h. The letter h is of 40 meters, and the radius, this is the cross-sectional view of cylinder. Okay, the front cross-sectional view, front view of the cylinder. Okay, you cut like the Coca-Cola can and you see the rectangle shape like this. Radius is 1 meter. Okay, you can see that it's if the volume of cylinder, right? It's, we say there is gonna be, what is that? It's gonna be pi r square h, right? The cross-sectional area times the depth, which is the height here of the water. Okay, that's the volume of cylinder. Calculate the force, the weight first. Force exerted by the air on a distance radius 1 meter. Okay, yeah, we need to know the force down. And what pressure at the depth of 40 meters. Okay, supports the water column. Okay, there are three main questions in this problem. Okay, let's go ahead with that. Yeah. The weight of the cylindrical column of water, right? So if we have the pure can or pure cylinder like this, and we fill the water in. We pour the water into this, okay, water, and we fill it until it's full. Until the can or the cylinder here is full of water, we get weight, right? They want to know weight of the water, right? So the weight of water is going to be mass of water times g, right? The acceleration on Earth, and we know that the mass of water is rho water times v, right? Mass is density is mass divided by volume, and we move volume to the right hand side. Volume of what? Volume of cylinder. Okay, because we consider only the shape of cylinder, water inside cylinder. So yeah. And what is V cylinder? V cylinder is, as we know here, pi r square h. And we substitute both expression into this one, right? We're gonna have W weight water will be equal to mass, right, which is the rho water, and times pi r square h times g. All right, many variable, but it's not too difficult. Rho of water, of course, this is the pure water or seawater. They say only simply water, right? So oh my god, no, not this one. We're gonna use the pure water density, which is 1000 10^3, and pi, right? Pi, and r square, r is the radius of this one, which is known here, okay? R equal 1, right? R equal to 1. So this is the one with the power of 2, and the height is 40 meters, and g is the acceleration of 9.8, right? You put it into the calculator, and you would get the excellent number. It's 1.23, okay, approximately Newton. That's the weight of the water in this shape, okay, the cylindrical shape. The second question is calculate the force exerted on the air by the air on a disc of radius 1 meter. Okay, we consider the lid, the upper lid of this can, of this cylinder. We would have here a disc, right? Radius here is 1 meter, right? The radius is 1 meter, and the force exerted on this, right? There's attractive force of the gas, the air molecule to the water molecule, right? And here is F perpendicular, right? According to the definition of the pressure, right? And as you know, pressure is F perpendicular by A. So this one is here. Here we need to determine the area of circle, right? Air on a disc, okay? A disc A disk, it's a circle, right? So area is equal to area of circle, which is pi square, right? And F perpendicular, F perpendicular will be equal to, pressure is F by A. So if you want to find F, you have to move A to the pressure, right? Pressure times A disk, okay, A disk, P, the pressure, pressure is P ATM, right? We need to write down also here the detail P ATM, because we observe this at the atmospheric temperature, atmospheric pressure. So P ATM, what is that? P ATM is 1 point here, 0.01325 times 10 to the power 5, and A disk is pi, R is number 1 square, right? You put it into the calculator, you're gonna have F air, which is 3.1832 many times 10 to 5, and the unit for this is Newton, right? It's quite heavy. Okay, the next thing is that what pressure at the depth of 40 meters to support the water column. And as you know, we need to sketch the free body diagram, right, of an object. Okay, this is the water, this is the front cross-sectional view,